Welcome to our weekly conversations on artificial intelligence with thought leaders in Africa. My name is Zenzele Ndlovu. I'm the head of research and market development at Machine Learning Africa. We attempt to provide insight into AI and other emerging technologies and their inevitable impact in transforming business and the broader society. Please check out our upcoming event, the AI Business Conference. You can register for free at aiconference.co.za. Welcome to another edition of our conversations with AI leaders in Africa. Again, we have a very special guest today, and I will ask my colleague Johan to introduce our guest. Johan?
Zenzele, thank you so much. It's wonderful to speak to all these people in our local market doing amazing things. And today we have Dr. Michael Grant, who is the Chief Technology Officer at DataProphet. He is a machine learning expert. He's got his PhD from a local university, and if you look at his LinkedIn, he's an award winner. And I know you guys are doing great things, I think if I remember correctly, Mike, especially in manufacturing, but welcome and thank you so much for your time.
Thanks, Johan and Zenzele. It's really good to be here and to chat with you guys. And I think these Zoom calls are the way of the future. So this is my first Zoom interview, so you're going to have to excuse all the mistakes I made, but I'm looking forward to chatting to both of you.
Appreciate that. I always say to Zenzele when we chat about these things, it should feel to our listeners like we're sitting in their living rooms, just a nice chat about, and I think the important thing for us is you know, everyone comes to these topics about smart technology through different lenses. And it's interesting to hear people's different takes, and that's how we're learning, Mike. So maybe if I could kick it off, asking you, what is DataProphet? What's it all about? Please tell us.
DataProphet is so exciting. We have too much fun. What we do is we apply artificial intelligence to manufacturing to make it better. And that make it better can be improving like a scrap rate or a rework rate. It can be reducing energy consumption. It can be minimizing waste material production. Improving machine OEE, all of these problems. And what gets me even more excited is the fact that we've managed to solve this with a single AI. So often what you find is that folk go out there and they go and make a little bespoke thing that works just for one person, and then they got to go and do the next, and they've got to go make a new little bespoke thing for just one person. And what gets me terribly excited is the fact that we've done this with a single AI service that is able to abstract across all of these different domains. And so I've got an AI system that runs a fish meal processing plant, and it also runs a gray iron foundry. And I'm experts in neither, but my AI is pretty good.
Thank you, Mike, for that. You know, as DataProphet operating within the manufacturing space, and of course, you also operate in different markets internationally, got presence in the US and Brazil and across Europe as well. I wanted to find out maybe how has been the uptake from the local market, you know, as far as Industry 4.0 is concerned. Would you say that there is appetite from the local market when relative to the international markets that you say?
This is a good question, and one that is very important to South Africa, because when we look at South African manufacturing, we find that it grew out of a support for our mining activities. So primarily these sort of supporting roles to generate the equipment necessary to either extract minerals out of the ground or support the operations around those activities, or in fact to house folk, right? So it was always in that supporting role. South Africa now finds itself in the unenviable position where the minerals are too deep or too rare, too scarce. And we've got this transition away from a commodity extraction-based economy. And so folk then look at, well, we've made this tech to support mining. Where else is it applicable? And so some guys get this right, and they're able to export their technology into global markets. So particularly, for example, some of the mining services guys who've come up with really good processes now have, for example, sold some gold processing equipment into Peru, where the gold is no longer as deep, which is nice for those niche ones where the guys have some intellectual property or some sort of competitive advantage. But outside of that consumption, South African manufacturing has really been on the decline. We look at equivalent products coming out of the world's factories, right? So out of the East, out of India, out of Brazil. And we see that they're able to land on our shores at a price that is cheaper than what it costs to make here. And that landed price obviously includes some kind of markup. And so we have this very big disadvantage. And South African manufacturing has now been on this constant decline as a result of this, right? Because consumers are simply going to follow their pockets. And so we observe this transition to a service economy where the last few remaining South African manufacturers are predominantly here because their owners are sweating the assets. We don't see a lot of investment in manufacturing. And predominantly, in my mind, I think that's on the back of this massive skill shortage that we're experiencing here, where we have a workforce that is very expensive, but comparatively very expensive. So you've got this huge workforce, very expensive to run and not quite as well educated compared to what you would get for an equivalent amount rate in, say, the Far East. And this is where Industry 4.0 becomes the game changer, because applied properly, it minimizes that deficit. And don't get me wrong, right? I'm saying South African education is absolutely crucial. It's a topic that's close to my heart, and it's something we've got to get right as a country. And it is a passion of mine, but Industry 4.0 has this power to make that difference irrelevant when arguing for a product, right? So now South African manufacturers can say, we've got this technology, let us produce your stuff for you. And I've got a success story. And I have such an exciting success story where you have a South African company that was sort of been around for 45, 50 years and is globally competitive on the back of my technology, who ships their product to Daimler, right, into Mannheim, into Germany, because it is better made here in South Africa than anywhere else in the world. And that is cool.
That is very cool.
Absolutely.
And you bring me to, because I wanted to ask you as you were speaking, like, is there a future for manufacturing in South Africa? Because, we're kind of bombarded with all the negative news. But there must be a future, but it must come with this kind of technology. So what do industries, what do they need to do? I think there's such a misunderstanding and maybe a fear about this technology. Where do they start to make sure they are globally competitive?
Yeah, that's a good one, right? And so I think South Africa sits, you've got these sort of general manufacturers who can make things, and they need to go out and convince their clients, right, who may not be the direct consumer. Often you get the stuff made under consignment. So you'll go to a manufacturing house to get something made. And they've got to go and convince that guy that the quality of the product that they're getting is as good as, if not better than, what they would have gotten at the same price. And then you've got to compete in terms of costs, customization, service, and delivery. In addition to that, and all of these aspects have dimensions where things like AI become important. But it's not a point where you say, I'm worried about AI taking my job. Because at the point where South Africa is at, it's about not using AI and you don't get the work. So if you think of it, that classic FOMO, it could quite literally be the killer of your business, because if you're unable to remain internationally competitive, your business is already checking into ICU.
Okay. Mike, I can imagine, trying to solve some complex problems, optimizing the manufacturing processes and so on. Obviously, you need massive data, to perform your work or to optimize the processes. How do you acquire, the volumes of data, and how difficult it is for you to prepare that data for artificial intelligence?
Also a good question. So I think we're looking at this problem from a classic data science perspective. When you do that, you say,
okay,
how much data have I got? Okay, I need more. That's the classic way of looking at it. And particularly in building this system, we've managed to get incredible results on a very low A, dimensionality, and B, depth of records. So as few as 6 dimensions, so 6 parameters from the manufacturing process, and as few as 800 observations. That's not a lot by any measure, right? And I think that it speaks to the fact that we have this validated AI system that means we don't need the breadth of data we would need to go and prove out that concept. We know what the architecture should be. We know how the system should interact. We know the kind of results we're expecting. And therefore, we can run forward on a lot less data, which means that a lot of processes that are not as digitally mature or without an extensive digitized history are now suddenly available for us to go and optimize. But on the converse side, I get to brag. We do like processes within 20 different production steps with a dimensionality of 6,500. Now that's quite a lot of degrees of freedom, right? There's a lot of things to go and change. And what we're able to do in exactly the same system is to go and say to the plant operator, of the 6,500 things that you need to change, the one that matters the most is this one. And this is how much you must change it by. And so we're able to reduce the dimensionality in terms of the operational problem, the operational thing of knowing what the right thing to do next is. And at the low dimensional level, we're able to get insights into very complex interactions between these 6 degrees of freedom that have been able to improve a process beyond any human optimization approach. And so the answer is, you've got to connect the data, you've got to uplift it, you've got to have some record, but it doesn't need to be extensive. It doesn't need to be many decades of history. Just a few observations is in fact more than enough.
Yeah, it's interesting because I would think it is incredibly complex. What are the things that will cause DataProphet to not be able to help a client? What are the things, once you get going with say a new client, what are the things that makes you go, unless you do this or that, we can't really help you?
Johan, there are 2 aspects, right? So we've had clients where they have had and they've refused to digitize their system. They've said, we've got the paper records. And so we went and we did a digital upliftment program where we scanned them in, and we used a team of data capturers around the world to actually create a digital record. And we were able to optimize that plant without even connecting in at the digital layer. So that's not a blocker. And we've had clients who say, this process is not controlled, but we want to know what it should be controlled to. And we're able to say, okay, now you need to go and get a control system that has a control bound of the following, and it needs to have a response time of the following time, and therefore you must use this actuator, not that one. And they've gone, okay, great, and they've done the investment, and they've realized the uplift from that. So failure to control is not a limiting factor. The hardest thing, the absolute hardest thing that I face is going to an engineer who has 25 years experience on the plant, who has seen it all. And here I am, and I'm not an expert in his process. And I say, in that calciner, you've got to increase the temperature by 40 degrees. And he looks at me and he says, well, that's nice. Let me tell you what my experience is. And so it's this journey of trust. And this isn't something that the clients get wrong. Right? It's one where we've got to support the integration team to get right. And so we found really good things, like folk will say, okay, we've got this R&D program, which means that if you produce scrap during this phase, it's not going to account against your KPIs. So the stick from the production side is now absent. We can now go ahead and say, okay, we can run this trial, and the production team can implement it without fear of reprisal. There's a big one. And then we obviously do a very deep commissioning test to convince folk to trust the results coming out of our system. We do those 2 things right, and we're good. We do those 2 things wrong, and we fail.
Mike, even though you and the organization focus on manufacturing, I think you've just touched on something very important. And I think we underestimate the people aspect of this technology. Because like you've just said, it's somebody who's got all this experience. and you're not an expert in the field, so they most likely already mistrust you, or you don't have the credibility that they might think you need. I see the same in banking and financial services, where because people have been either a banker or a senior manager, exec in the bank, and now we're having a technology conversation. So I think the important thing that you've just touched on for me is answering the fear question, which I think we should not avoid. We should not just speak about platforms and data and AI. It's how do we help you without you losing your job? So maybe just before we conclude, any comments on that maybe?
A couple. I got to see a demo the other day where folk were using a video stream to sort of tag some objects in it. And the result of this was actually really good. Like, looking at it and sort of assessing the kind of result, it was better than state of the art. So this got me really excited. And I went and had a good look, and I was chatting with the folk who put it together. And he let slip, oh, no, it's okay. We're so good because we have humans in the loop. And in some regard, we often try to deal with this trust of AI systems by putting people in. But too quickly, we start using people as the primary value add in the loop, which defeats the purpose of having an AI system. And so we've got this sort of like dichotomy. You've got to somehow put a person in the loop to create trust, and somehow you've got to remove a person from the loop to add value. Because to be absolutely clear, the guy with the video stream and the humans in the loop is committing fraud because there is no AI, right? He's just using people sitting at the back there frantically tagging a video stream when he should have built a proper AI system and didn't. So we've got a lot of folk who go out there saying, my system brings AI, it's really good, buy mine. And when you interrogate it, the value isn't there. So it's been oversold in that domain, and we've got to build trust in that dimension alone, right? And then you've got this next group of folk who say, it's all about explainability, right? You've got to be able to say the results of the AI system is explained in terms of these set of inputs, which is great. And so you can go and say, well, it's the combination of this plus the combination of that plus the combination of that, which very quickly exceeds the science. So in other words, your AI system could learn a relationship that is not explained by a known physics, right? It could be because the physics is unknown. It could be because it's a spurious correlation, right? Or it could be that there's no causation involved. And so now when you look at this explainability, they get to say it's explainable, and then the experts say, well, to me, it's not. And so you've got this fundamental technology mismatch in terms of what is it actually learning? Does it matter? It does. Then you've got this next group of folk who say it's not about correlation, it's not about explainability, it's about causation and causality. And here they're looking to sort of establish causal links in a model to say, well, this happened, and then as a result, that happens. They call these things counterfactuals, right? And this is quite nice. It creates a lot of like sort of feeling of warmness inside folk. But when they start interrogating it, what they find is in fact that these guys have just embodied a first order model of a problem, and you actually haven't got a deep learning system. So it's kind of like a sidestep around AI back to the early days of analytical empirical twins. It's not the right thing either. So the right thing to do is to say, well, you've got this system, and here's how we're going to test it to your satisfaction. And that's the trick, is you come in with the technology, and then with your customer as a partnership, you validate it to the point of their satisfaction. And once you get that right, then everything changes, because now they're saying, right, we've tested it. There's been a commissioning test. These were the involved examples. We can black box this, but we validated that A, the causal requirements are met, B, the spurious correlation requirements are met. Yes, we're happy that there's no human who's actually driving this, like the mechanical Turk, hidden under a table. There's none of that. And so you've got this proof of value that you can then go forward. And then once you get that right, it all changes.
Yeah, but Mike, thank you so much for your time and chatting with us and sharing your thoughts on Industry 4.0 in South Africa and the great work that you're doing with DataProphet. It's been a pleasure chatting with you.
Thank you very much for having me, folk. And it's an open invitation to yourselves and your listeners to hit me up at mike@dataprofit.com. And these are the kind of conversations I love having. And if it means helping you transform your business, I'd love to get that going.